Welcome to today's webcast, Distributed Version Control, using Git in VS 2013. My name is Colin Dembowski. I'm an ALM MVP based in East London, South Africa, and I work for a company called Imaginet. My Twitter handle is Colin Dembowski, and I blog regularly to colinsalmcorner.com. Before we start today's webcast, I'd like to tell you a little bit about Imaginet. We have over 650 successful ALM customers and over 1,800 successful ALM engagements. We're a Microsoft Gold certified partner with the ALM competency, and in 2011 we were Microsoft's ALM Partner of the Year. We have only the highest level of expertise with Microsoft ALM technologies and a close working relationship with Microsoft. On staff, we have multiple Microsoft regional directors, TFS rangers, virtual technical specialists, and many Microsoft MVPs. In today's screencast, we're going to look at modern source control approaches. We're going to discuss distributed source control, look conceptually at TFS Git integration, and then we'll move into the demo. There are a couple of modern source control approaches. TFS, since 2005, has used the check-in, check-out model. Subversion, on the other hand, is more an edit commit based model. With check-in, check-out, you'd have to check out exactly which code you want to from the repository before you can work on it. Typically, the repository is also going to lock files that you check in so that you can't change them while you're disconnected from source control. This introduces a lot of friction. The edit commit model, on the other hand, allows you to get files from source control and change them and then check in whatever edits you have. Since Visual Studio and TFS 2012, local workspaces enable the edit commit model, while server workspaces continue the check-in, check-out model. These are both centralized version control techniques. There's a growing trend in the industry for distributed version control, typically through Git and Mercurial. Distributed version control gives you a full offline experience with a complete repository being hosted locally. It has a simplified branching model and is best for modular code bases and integrations with open source projects, and of course highly distributed teams. Let's look at distributed version control in a little bit more detail. With distributed source control, you would have what's called a local repository. This is a complete history of every change that's been made to the source that's under source control. Locally, you'd be able to commit or check your changes into the repository, branch, and of course merge your branches back in. When you want to publish those changes to other team members, you would do what's called a push to some sort of remote repository. The push would take all the changes you've made locally and push them to a remote repository. Other users would then clone that remote repository locally. Remember, this creates a complete copy of the repository, including all the history and all the changes that have ever occurred in that repository. Once you're ready to bring changes from the remote repository back into your local repository, there are two operations. A fetch will allow you to preview those changes, and a pull will bring those changes into your repository. Of course, there may be many other users that are pushing and pulling from the remote repository to their local repositories. If any of these repositories is lost for some reason, that's okay, because the local repository is the entire repository. Let's look at how TFS and Visual Studio integrate with Git. Here we see a team project called Project 1 that has a central version control repository or TFVC repository. To connect to that TFVC repository, you'd use either Team Explorer or any third-party plugins like the Eclipse Team Explorer Everywhere plugin or Team Foundation Server Power Tools Shells plugin, and there are other plugins that will allow you to interact with central version control. With Team Foundation Service and TFS 2013, you can now create a project that has a Git source repository rather than a TFVC repository. You still get access to issues or work item tracking, project management, and build, and so a lot of those features around application lifecycle management stay the same as a TFVC project. The only difference is that the backend for the source repository is now Git rather than TFVC. Team Explorer implements a Git source control provider, which is backed by libgit2. This allows Visual Studio to interact with any Git repository, whether that's a local repository or some other remote repository, for example, a repository sitting on GitHub. This is just Git. This is not some sort of special Microsoft version of Git, and so it'll work with any Git repository. Of course, because it's just Git inside, that means that any third-party application that can interact with Git will be able to interact with the Git repository sitting on TF service or on a TFS 2013 Git team project. That could be through Xcode or Eclipse or various other shells. Finally, there's a tool called GitTF, which has been around for quite some time, which allows you to clone pieces of repository between TFVC and Git. When you work against a Team Foundation server project, either on TF Service or TFS 2013 hosted on premises, you'll see that there's some functionality that doesn't work like it does against TFVC team projects. These include code review, my work, and code lens integration. However, you'll still get integration with work items and with builds, both of which we'll see today in the demo. Let's look at how we create a team project that has Git as a source repository. If we go to File, New Team Project, we'll first have to select a name. Then we'll have to select what process template we're going to use. This defines what work item types we have available, what default reports we have, and other settings for the project. On the third page, we'll see that we can choose from two repositories, either TFVC, or centralized repository, or Git. I've already created a Git team project. Let's open up the web access page for my server and connect to the Agile Git team project. You'll see this team project looks like a TFVC project. I can go and create user stories, tasks, bugs, and so on. I can view my backlogs and task boards. I can create work item queries and so on. You'll only really notice the difference on the code hub. Here we can see that we have a repository called Agile Git, and the repository is currently empty. Let's connect to this team project using the Team Explorer. I'll open up Visual Studio and go to the Team Explorer tab, and we'll hit this Connect button. There you can see the Agile Git team project. It has a different icon to show that it's got a Git repository. We'll double click that to connect to that repository. You can see I have access to work items, builds, reports, and settings, as well as some other tiles that are specific to Git, like unsynced commits, branches, and changes. However, the first thing we'll need to do when we work against a Git team project is clone the repository. I'll hit this clone this repository link here. Now this URL is the Git remote URL. We could give that URL to anyone who's going to interact with this repository, whether or not they're using Visual Studio, and they'll be able to push into this repository. Let's change the directory. And select Clone. Team Explorer has now cloned that repository for us. Let's click on Settings and set our global settings. Here under Git, there's a link to Git settings. Git requires your username and email address for any commits that you do. Let's enter in an email address. We can also change our root repository. And we can also enable download of author images from third-party source. This is useful if you've already got an avatar in a website like Gravatar. We can also add default ignore and attributes files. These are useful defaults to filter out files that we're not interested in bringing into source control, like compiled libraries. Let's hit Update to update our global settings. Let's go and put some code into that repository so that we can source control existing code. I'm going to open up a file explorer to the Agile Git directory. There you can see the .git attributes and .git ignore files that we added. You can also see this hidden folder called .git. That's the file that actually contains our repository. You don't ever really want to mess with those files. I'm going to paste in a folder called calculator, which has got a solution and some projects in it. Let's go back to the home page in Team Explorer. Here you'll see under the Solutions section that Team Explorer has detected the solution in our local repository. We'll double-click the solution file to open it. If we go to the Solution Explorer, you can see that we currently have no source control for any of the files. I'm going to right-click the Solution node and select Add Solution to Source Control. You'll see we get the familiar plus icon showing that there's a pending add operation. Let's go back to the Team Explorer and go to Changes. And here under Changes, you'll see a list of all the changes in our current version of this repository. They're all adds at this point in time. Let's add a message here and hit commit. You'll see that we get a hash. Each commit against a Git repository creates a hash that uniquely identifies that commit. Let's go and make a change to a file in our solution. I'll open up this math basic file and we'll add a comment here. If I then go back to the Solution Explorer, you can see that there's a pending edit icon against the mathbasic.cs file. If I go to Team Explorer, you'll see under Included Changes, there's a pending change for the mathbasic file. We can of course commit this again using the Changes window. However, a lot of users interact with Git repositories from the command line. Let's see how we can interact with the command line. Before we do that, let's go and check what tasks we have assigned to us. I'm going to open up Work Items and double-click this My Work query. I see that I have a task 250, to add the cos function to the calculator, as well as a bug, calculator multiply does not work. Let's add the cos function to the calculator. We'll go back to the math basic file and we'll implement the cos function. Let's save that change. I'm going to open up this PowerShell console. I've installed poshgit, which allows me to interact with a Git repository from a PowerShell command. Let's go into Agile Git. And here you can see poshgit is telling me we're on the master branch and we have one pending change. Git allows us to stage changes before we commit them into the repository. To stage this change, I'm going to type in git add. You can see the color changes now from dark red to dark green, showing me that I have a staged change. To commit that change into the repository, I'll use git commit -m to supply the message. Now since this was for task 250, I'm just going to use the hash notation and select hash 250. That'll associate this commit with that task. We'll hit enter. We've now committed that change in. If we go back to Team Explorer and go to the Changes window again, you'll see that there's now no changes. Let's select Actions and view History, and here we'll see the commit that we did from the command line is in the history for this repository. Now at this point we've only been working against the local repository, and so no association has yet been made between the commit and the work item. That association will be made later when we push these changes to the remote repository. One of the most compelling features of Git is its branching mechanism. The branches are very lightweight and you can throw them away once you're finished with them. And since they're working on a local repository, no one has to see any of your branches if you don't push those branches to the remote repository. Let's go and create a branch. We'll go back to the Team Explorer, select Home, and then select Branches to open up the Branches page. We'll select this new branch, link, type in dev, and we'll check out the branch, which will put us immediately onto the dev branch. If I then open up my poshgit console again and do a dir, you can now see that poshgit is showing us we're currently on the dev branch. Let's make a change in the dev branch. We'll make it to this multiply method here. Let's go back to the Team Explorer, to our changes page, and commit that change in. From the Changes tab, we can see the branch that we're currently on, and if we expand the arrow here, we can see other branches. Let's switch to the master branch. You can see that our code immediately updates to the code that's on the master branch. Let's make a change to this file. We'll fix the multiply bug. We'll change the operator here and add a comment. We'll enter a comment, and we'll also use Team Explorer to add the association to bug 251. Finally, we'll commit to commit those changes into master. Again, let's change back to dev. Let's go back to master to see master's file. Now in this case, we've changed the same lines in the file. So let's see what happens when we do a merge. We'll go back to our home and select branches, and we'll select the merge drop down. This will allow us to merge from one branch to another. Here we want to merge from dev into master. I'll hit the merge button. Now if we change different files in those branches, they would be auto merged. In this case, we've changed the same piece of code in the same file, and so we'll have to resolve the conflict. We'll hit resolve the conflicts, and that'll give us a list of conflicting files. There's only one in this case, the mathbasic.cs file. If we click the merge button, that'll open up a three-way merge for us, where we'll be able to visually merge the conflict. You can see that we get IntelliSense and color syntax highlighting in the merge dialog. We'll click accept merge to accept the merge. If we go back to Team Explorer, there's a commit merge button here, which we'll click, which will fill out a default message for us and allow us to commit the result of the merge. Again, let's pull down actions and go and view the history. Here we can see a change that was made on dev, another change in master, and finally a merge that occurred on master. Now that we've made several changes locally, let's see how we can push them up to the remote server so that other team members have access to those changes. We'll go back to Team Explorer and click on Unsynced Commits to open up the commits page. Here we can see a list of commits that we've made locally that are pending. They're shown as outgoing commits, which we can then push. You can see that we've successfully pushed those 5 commits to Origin Master, which is the remote repository sitting in our team project. Let's open up Visual Studio as another user. I've opened up Visual Studio here as Brian. He has just cloned the repository that we've been working against. Let's go and open up the calculator. We'll open up the MathBasic test file, and we'll create a new unit test. Let's go and commit those changes in. Go to Team Explorer, hit Changes, and type in a message, which will then commit. We'll then go to Unsynced Commits and push that change. Let's switch back to Adam's Visual Studio. Adam may want to preview any changes that have been made to the local repository before pulling them into this repository. Let's hit this fetch link to see if there's anything waiting. Here we can see that there's a change that Brian has made. We can right click and select View Commit Details to see the details of Brian's commit. Here I'm going to right click the MathBasic test file and select Compare with Previous to see what changes Brian has made. You can see that he's added a unit test here. If we're ready to bring those changes in, we can go and pull those changes in. You can see our repository has now been updated. If we go back to Home and to Changes and then view the history again of this repository, you'll see that we now have a change in our history from Brian Keller. Let's go and have a look at what the repository looks like in Web Access. We'll go back to the Web Access page and hit refresh to refresh that repository. Here you can now see that we have contents, and if we go to history, we can see all of the commits that have been made against this repository. Let's click this Fixing Malt Bug commit, and here we can see that it's associated with bug 251. If we open up bug 251 and look at the links, you'll see there's a link to the commit. We can also see an inline view of what's changed in this file, in this commit. We could change this to side by side by clicking on this button in the toolbar. We can also add comments. Let's select this line of code and hit Add Comment to add a comment. You'll now see if we expand the Math Basic file, we can see a list of the comments for that particular file. Clicking on Math Basic gives us a diff view, so we can see the difference between the previous version and the current version of the commit. We can also annotate the file by clicking on the Annotate this file button in the toolbar. This will show us which portions of the file came from which commits. Finally, if we go back to the Explorer, we can select any file or folder, and if we expand the menu, we can download as a zip file. Let's see how we can create a build definition for a Git repository. I'll select Builds to open up the Builds page, and we'll click New Build Definition. We'll give this a name, Calculator. For trigger, we can select most of the triggers that are available against TFVC, except for the gated builds. Let's select Continuous Integration so that every commit triggers a build. Under Source Settings, instead of creating a workspace like you would against TFVC repositories, you select a repository and a branch in the repository. Under Build Defaults, we can select whether to copy the outputs to a shared folder or whether to check the outputs back onto the server. Under Process, we'll use the default template. Let's browse to the solution. Once you've selected the solution or the projects, the rest of the settings are pretty much the same as you would use from TFVC builds. Let's save that build definition. Let's trigger that build. I'll right-click the build definition and select Queue New Build. You can see the build is completed. We can see a list of the solutions that it built, as well as see any test runs or any other build information that's applicable to our build. If we open up the drop folder, we'll see the compiled binaries. I've shown you how we can interact with a Git repository that was cloned from a team project. We can also work completely disconnected from Team Foundation server, just with local repositories. If we go back to the Team Explorer, we can click this Connect to Team Projects button. That'll show us any projects that we're connected to, but there's also a section called Local Git Repositories. I'm going to select Add to add an existing Git repository. I've got a repository called Demo in this folder, and I'll click Add. You'll see that local repository is now listed. I'm going to double click to connect to that repository. You can see some of the tiles are now not visible, like work items and builds, since we're not connected to a team project. Let's go and open up the solution. Again, we'll be able to make any changes we want to and commit them to that repository. But what happens if we want to push a local repository that we've been working against into a team project? Let's go back to Team Explorer, go to Unsynced Commits, and here you'll see there's a section to publish to remote repository. This prompts us to enter the URL of an empty Git repository. If we go back to our Git team project, Agile Git, you'll see that we don't have an empty repository. We've got a repository that actually has some contents. We won't be able to use that. Let's create a new repository in the team project. I'll expand Agile Git and select Manage Repositories. This will open up a page which will allow me to create additional repositories on this team project, as well as manage security for each repository. I'm going to click this new repository and create one called Demo. That'll create an empty repository called Demo for me. Let's go back to our Code Hub and refresh the page. And then I'll expand this Agile Git dropdown and we'll switch over to the Demo repository. You now see we get the page that tells us this is an empty repository. There are instructions about how to clone this empty repository or how to push an existing repository. We can either use the command line command here, or we can just copy the URL and do it from Team Explorer. Let's go back to Team Explorer and paste in the URL and hit publish. If we then go back to that repository on web access, you'll see we now have code in that repository. Unfortunately, because we've just created that repository, we're not going to be able to connect to it to get work items and build integration until we've closed and opened Visual Studio. We also need to reconnect to the Agile Git team project. I'll hit Select Team Projects, select VSALM, and disconnect from the Agile Git team project. We'll then close Visual Studio and restart Visual Studio. And we'll hit the Connect button again. And now we'll reselect the Agile Git team project. And we'll hit refresh. And now you can see that Agile Git is expandable, and we can connect either to the Agile Git repository we cloned earlier, or we can click this demo repository. Let's double click demo, and here you can see we've now connected up to the repository that we've pushed up onto the team project from our local repository. Let's see how we can connect to a remote repository that's not a Team Foundation Server repository. Let's again go to the Connect page, and I'm going to select Clone, and I'm going to paste in a GitHub Git repository URL. We'll select a repository for that and hit this Clone button. The repository is now cloned, and if I double click that, I'm able to see all the solutions as well as any changes, create local branches, and sync my commits back once I'm ready to push them back to the repository. Thank you so much for attending today's webcast. I'll now hand over to Becky, who will tell you some more about our upcoming events and special offers.
Thank you, Colin. Would you like to know more? ImagineNet offers a variety of free webcasts and events. To see a listing of or to register for any of our free webcast or roadshows coming up soon, you can visit our website at www.imaginenet.com/events. Our next round of webcast topics include new topics such as top business benefits of application lifecycle management, What's new for ALM with Team Foundation Server in Visual Studio 2013? Enterprise Agile Management with TFS 2013, improved developer productivity, managing test labs without the headache, and coded UI testing with Visual Studio 2013. If you enjoyed today's webcast and are interested in adopting Team Foundation 2013, ImagineIt can help. We have our TFS 15-day adoption quick start. This includes designing, installing, and configuring your Team Foundation server and the Visual Studio development tools. ImagineIt will teach you and your team the best practices for source control, build and release management, agile methodologies, and work management processes. It also includes support and training for your team and includes a high-level ALM assessment. If you're interested, just email us at info@imagineIt.com. Similarly, if you already own Team Foundation Server and are interested in upgrading to the newest version, ImagineIt offers our TFS 2013 15-day upgrade quick start. This includes planning and upgrading your existing Team Foundation Server to the newest version. We also covered the new best practices that exist in TFS 2013 around source control, build, agile methodologies, and the work item tracking processes. In addition, you will get support and training so your team is familiar with how to use the new features of TFS, and also includes a high-level ALM assessment. In addition to these two offers, ImagineIt also offers a wide variety of ALM planning and implementation services. This includes other upgrade services, remote support, quick starts around lab management, manual testing, automated testing, and load testing, and also integration services that allow you to integrate Team Foundation Server with other products and tools. Finally, visit our ImagineIt Visual Studio website. It's really your one-stop hub for all of your Visual Studio needs. Just visit visualstudio.imagineIt.com. You'll be able to find all of our consulting services, training services, roadshows, and webcasts in one place. For any other questions or for more information, please feel free to contact us at info@imagineIt.com or by calling 972-607-4830. Thanks again, and we hope to see you on another ImagineIt webcast.